Hi everyone, welcome back to my YouTube channel SK Tech. In today's video, we are going to discuss about the stack in Java, and we are going to cover what is stack class in Java, how to create a stack class, all implemented interfaces, methods of stack class. Okay, so let's begin. So let's see first the hierarchy of the stack class, where it is belong. So as we know, iterable is the root interface, then collection, then list, and these are the implemented class. We have already seen vector class implementation in our previous video. I'm going to share the video link in the detail section, so do check out. And stack class. So stack class is nothing but the extension of the vector class only. So let's see what is the stack class. So basically stack class extends the vector class and it is its subclass. Okay. Basically it's work on the principle of last in first out. So what are the elements that you are going to insert inside the stack? When you get the element, you will be getting the last element which was inserted. So that's why we can say that it is going to work the principle of last in first out, or you can say first in last out. That is the nothing but the reverse order. So in order to put an object on the top of the stack, we call the push method, and to remove, or you can say return the top element in the stack, we call the pop method. So these are two main methods available in the stack class. One is push method to add the element inside the stack, and one is pop method, that is nothing but to remove the element, or you can say return the top element in the stack. So basically it will get the element and also it will remove the element from the stack. We will see with the help of the example also in couple of times in a minute. Okay, and there are some other methods like peek, search and empty method which are used to perform the operation on the stack. We will see this implementation also, what is the use of the peek, what is the use of the search and empty method. Okay, so this is what I was talking about this stack. So this is how it will be look like. It will be look like one jar, and then you will putting the element inside the jar. So something like that is called stack in Java or in the data structure. So to putting the element inside the stack is called push operation, and to getting the element from the stack is called pop operation. And peek means just looking the element and getting the element. But pop is like when you get the element, it will also remove from the stack. But if you are using the peek operation, it means it will just get the element but it will not remove from the stack. So this is nothing but the basic structure of the stack class. Okay, we'll see with the help of the example also. So this is one of the data structure which is implemented by the Java, and that is called as stack class. Okay, now let's see how to create the stack class. How can we create that and how can we use it in our programming? So this is the one way we can create the stack using the default constructor. So there are a couple of the constructor provided by the stack class. So one is like default constructor. So here we can provide like stack and data type. This is nothing but the generic, means what types of the data that we want to insert inside the stack class, and then object equal to new stack and then save data type. So here it is a default constructor. Now let's see all implemented interface that is implemented by the stack class. So basically we know that as per the hierarchy, stack class is extending the vector class, but internally it is also implementing the some of the interfaces. One interface like serializable, clonable, iterable, collection and list interface, and also it is a random access interface. So these are some of the basic definition about all of the interfaces. So as we have already know, collection interface, right? Collection is nothing but to represent the group of the object known as its element. Means collection interface is used to pass around collection of objects where maximum generality is desired, right? And we are also knowing like what is the list interface. So list interface is nothing but provide a way to store the order collection, and it is a child of the collection interface, right, as per the hierarchy. And also we know iterable interface, right? This is the root interface. So this interface represents the collection of the object which is iterable, meaning which can be iterated. Okay, apart from these three interfaces, stack class also implement the serializable or clonable and also random access. So serializable means, so it is a marker interface that classes must implement if they are to be serialized and deserialized. So basically any class, if we want to make it serializable or deserializable, those classes must be implement the serializable interface. So basically stack class can be serialized and deserialize because it's already implementing the serializable interface. We'll see what is the marker interface in upcoming videos. Then another interface implemented by the stack class is clonable. So what do you mean by clonable? So this is an interface in Java which needs to be implemented by the class to allow its object to be cloned. So similar to the serializable, if the class wants to clone, means either pseudo cloning or deep cloning, means creating the exact replica of the object, those classes needs to be implemented clonable interface, then only it will be allowed to be cloned. And random access. So what do you mean by random access? So this is the marker interface used by the list interface to indicate that they support fast random access. It means what are the classes is going to be implemented as part of the list interface. So element from those classes can be accessed randomly because all are those going to be work with the indexing basis. That's what we have seen as part of the array list, linked list and vector class, right? So these are a couple of the interfaces that are internally implemented by the stack class along with the vector class. Now let's see a couple of the methods available inside the stack class by which we can use it and we can perform the operation on the stack class. Okay, first is empty. So as the name itself suggests, like what is empty? It is going to return the stack contains some element or not. Then peek. So peek is the method which is used to peek the element from the stack. What do you mean by peek? It means that it is going to get the element, but it is not going to remove the element from the stack. And similar to the peek, there is a method called pop. So let's say if we want to get the element from the stack and also we want to remove it at the same time, then we will go for the pop method. Another method available is like push. So push method is used to insert the element inside the stack class. Then search method, as the name itself suggests, like search method is going to search the element which we have provided as part of the argument. Okay, so these are some couple of the basic methods available inside the stack class, and using this we can perform the operations. So let's see what are the operations that we want to perform as part of the today's video. So we are going to perform these of the operations. We are going to perform like adding the element, displaying the element, displaying the size, and pop the element and display it. Pick the pick method to find the topmost element and display it. Okay, so let's go to the our IntelliJ IDE and go. Let's perform this operation. Let's create another class basically to demonstrate this stack class. So let's say give the stack demo, and let's create main method. So let's first create this stack class object. How we can do that? Using the default constructor provided by the stack class. So something like this, new stack. And let's also provide the generics. So generic means what kinds of the data that we want to insert it. Let's provide like integer type for now. We can insert any kinds of the data. For now we are going to insert only integer type. And here also we can provide the integer. So basically this part is optional. You can provide it or not. Java is going to take care internally. So let's remove this. So let's say we want to insert the element inside this stack. So what are the methods available to insert the element inside this stack? That is nothing but the push. So push, let's say 101. Let's copy paste this and reinsert some couple of the element. So this is how we can insert the element inside the stack. Now let's print it. Let's use this simple sysout method and try to print this stack. Let's run this program and see the output. Yes, so if we can see that it is printing like 101, 102, 103, 104, 105 in a order which we have inserted. Right now let's see, there are two methods, peek and pop. Using that we can get the element. So let's see the differentiation. So let's first try to add some statement here just to be more visible. Okay, now let's try to perform those operations, peek and pop. So let's try to peek it. So let's see what it is going to print. So let's directly print it here only, and after the peek let's try to print it this stack list again and see the differentiate. And again we are going to perform the pop operation. Okay, and then again we are going to print the list. So then we will be able to differentiate it between these two operations, peek and pop. So let's run this program and see the output. Yeah, so if you can see here, this is the original list. It is having all the element. So when we have performed the peek operation, it's just that return the top element. That is nothing but the last we have inserted as a 105. So this element has been returned, and After that we have again printed the list. So if you can see, this list is not affected, all the element is still available inside the stack list, right? But when we perform the pop operation, it has given the top element from the list, right? But at the same time it has also removed that from the list. So we can see, if we printed the list again, you can see 105 has been popped up, it means it has been removed also. So this is the basic difference. Using the pop, it will get the element and it will remove from the list, but using the pick operation, it will get the element but it will not remove from the list. So according to the need, we can go for either the pick operation or the pop operation. Now next method available inside the stack class is search. Let's try to search some element. So let's say we want to print it like s dot search, and let's see, we want to search like 102. Let's see 102 is available or not, and let's try to add some statement here also. Okay, and let's try to run this program and see the output. So let's see what it is printing. So we can see that when we are searching that element 102, it is printing like 3. So it means search operation is going to return the index of the element, basically position of the element where it is available. So if you see G1, 2 and 3, so third position it is returning it here. So this is the search operation. Another method available inside this stack is like empty, right? So let's see what is the operation for empty method. So as dot empty, and let's write some statement again here. Let's run this program and see the output. Yeah, so what it is returning, it is returning true or false. It means that this stack is not empty. So basically empty method is going to return true or false. If the stack list is empty, then it is going to return true. If the stack list is not empty, it is going to return false. So these are some basic operations that we wanted to perform. So that's all for today's video. We wanted to discuss overview of the stack class, what is the stack class, what are the operations that we perform on the stack class, how to create the stack class, and what are some of the methods available inside the stack class. Now that we have seen that what is the stack, how to create the stack, what are the methods available inside the stack, and how we can perform the operation. Now let's see, now we will see where actually the stack data structure or stack class in Java is actually implemented or used in our real-time scenario. So first use is like function calls and recursion. So when a function is called, the current state of the program is passed into the stack. When the function returns, the state is popped up from the stacks to resume the previous function in the execution. That's what it is happening right in our programming. So when we call the any function from any other functions, what will happen? From the current function, it will go to the caller function, right? And from there it will perform the operation, and once the operation has been completed, it will again come back to the caller of the function, right? So this is happening because Java internally using the stack to maintain the previous states to back to the previous function. Okay, next use of the stack data structure, or you can say stack class, is undo redo operation. So if you know, if you're writing something and if you have, let's say we have deleted something by mistakenly and you want to undo it or you want to redo it, so how this operation is happening? Basically the undo redo feature in various application uses stack to keep the track of the previous action, and each time an action is performed, it is pushed onto the stack, and to undo the action, the top element of the stack is popped up and reverse the operation that is performed earlier. So basically undo redo operation is also performed with the help of the stack feature only. Next is like expression evaluation. So if we know the expression evaluation, right? So stack data structure is used to evaluate the expression in infix, postfix and prefix notation. So what do you mean by this? Operator and operands are pushed into the stack and operations are performed based on the stack's top elements. Basically when we are performing any mathematical operation in the Java programs and putting the statement like a plus b and then putting that inside the square bracket, curly brackets, so how the Java is identified from where the statement is started and where it is ended? Basically it is uses the stack data structure internally to maintain or to keep track all the open curly braces, closing curly braces, open braces and closing braces. Next use like browser history. So you can navigate from the one page to the another page, and again you can go back to the previous page also, right? How this is happening? Basically, web browser uses these tags to keep the track of the web pages you visited. Okay, so each time you visit a new page, the URL is pushed onto this tag, and when you hit the back button, the previous URL is popped up from this tag and it works. So this is another example of using the stack data structure by the Java. Next is like balance parenthesis. So stack data structure is used to check if the parentheses are balanced or not. What do you mean by balance or not? Means for every opening braces there should be closing braces. So that is called balance parenthesis. Okay, so an opening parenthesis is pushed into this tag and closing parenthesis is popped up from this tag. So if the stack is empty at the end of the expression, the parentheses are balanced. So basically Java internally uses the stack data structure to keep track or to keep the parenthesis balances so that it can identify is there any error or not. Next use of the stack data structure or stack class in Java is like backtracking algorithm. So all the tree data structure and all is uses the algorithm, a backtracking algorithm. So backtracking algorithm uses the stack to keep the track of the state of the problem solving process, and then current state is pushed onto this tag, and when the algorithm backtrack, the previous state is popped up from this tag. So this is very powerful algorithm, backtracking algorithm, and here also internally it is using this tag only to keep track from where it has been switched from one to another and then come back to the previous. So these are some of the real-time example on how the Java is using. Okay, so that's all for today's video. In next upcoming video, we are going to discuss about the queue interface and also its implemented classes like priority queue. So stay tuned. We'll meet you soon. Thank you.